Very good morning to everyone. Welcome to Pantech Learning. Sorry for the inconvenience. So let us start the session with the basic requirement and all. So before going to the starting of the session, I'll give some intro part about that workshop. Then later we will start. So I'm very happy to share this information with you all people. Myself Lakshmi from Pantech Learning. So this will be started for online and offline platforms for every people, for a student and research people. So Pantech Learning collaborating with for this workshop, PAL University. Thanks for giving this opportunity. So you will get better requirement. So the basic information you can understand here by using of this uh, workshop. So this will be about the 1.5 hour workshop. So that will be based on OpenCV for image processing. So we know very well about how the images and how the videos are making changes by using of different type of softwares and all, apps and all. So that purpose, if you want to do in real time application, which library you need, so you have to proceed, because by saying the words it's easy. The image processing we are going, and we are starting this what is the process of OpenCV with this. So that is and all easy only, but we want to understand those all those things. So we have to learn simple the basic information how we are using the image processing. So before that, let us start with the AI process. So I'm just starting with the basic introduction of the AI. So why I'm saying the AI means, in the AI only we are taking some particular part about the image processing. So that purpose I need to tell about the AI. So AI is nothing but artificial intelligence. So wherever you're having the intelligence with the human being, that information you're sharing with the artificial part, that you can say it as a artificial intelligence. Here you can see how the artificial intelligence is working. So if you are taking the artificial intelligence, along with that you need machine learning and deep learning. So means the machine learning and deep learning will work for to train the databases what you are giving. But today we are discussing image processing with the OpenCV is nothing but, so we are discussing some particular content is about image processing. So that image processing will work for images and as well as videos. If you want to work for the images and videos, then we have to use the image processing technology. But the technology, if you are going through with the coding part setup, definitely we should convert into some particular libraries that are only OpenCV library. So but if you want to work for that image processing along with the OpenCV library, but to train the data we need some particular algorithm, that is only deep learning model. So here we have to learn first what is a deep learning, then later we can go through with the image processing and all. So today we are learning about deep learning process first. So deep learning is nothing but it's an extension of the neural network. So you can see here in this machine learning, just we are taking input and you're getting the output because of single time training part of your database. But coming to the deep learning, it's not like that. So you're taking your input, so that input you're training with two more times, then you're getting the output process analysis. So this is the option when you're going with the deep learning. So why I want to tell about this deep learning means, because in image processing, if you want to train any type of database for the classification or any type of predictions, so then the deep learning will be easy to train off your database. That purpose we are taking today. So you can see most of the applications what I'm showing here, this is all are a combination of image processing along with the AI part along with the deep learning. Here you can see, by seeing of this picture you can understand. So we can find out the different type of emotions of the human being. That purpose you are taking this image processing with the deep learning along with the AI part setup. So now we will start with the basic image processing and all. Then later we can see how the image processing is working with the OpenCV, we can see. So first, so image processing is nothing but, before going to the image processing, in that you are learning two type of words, image and as well as processing. So means you have to learn about the image. So I'm starting with the basic process with the image processing with the definition of the image, because if you want to go some particular content, definitely the basics are very important. Because if you want to start the coding part with some particular language of the Python, then for real-time applications or for normal applications, definitely the basic of the Python language we should know. So like that here, so if you want to go through the image processing, what we need exactly before going to the image processing, the simple basic information we can learn here. So here I'm saying about the definition of the image. So image is nothing but, I'm just going through with the processing of the image. So what is the meaning of the definition means? It's a combination of the pixels. So we can say it as, the definition of the image is nothing but the combination of the pixels, or you can say it as combination of rows and columns, or you can say it's a combination of horizontal lines and vertical lines. How I can say the definition of the image means, so before going to the image, you can see like in your televisions, that may be a smart TVs with a LED or LCD, you can understand the picture with the horizontal lines and vertical lines like this. You can see the second picture like this. The picture will happen when you're near to the picture, then you can see the picture pixels like this, right? So the meaning of these particular boxes means what? The combination of entire boxes. Here each box is equal to each pixel. So I just want to tell the definition of the pixel, then you can understand what is an image of combination of the pixels. The simple thing, here you can see in this second picture, actually this is my first picture. From that first picture I just dragged this one and given that particular area of this dragging area to here with the pixel information. So here you can see small boxes and all. So each box you can call it as pixel. Pixel is nothing but least intensity value. So here the least intensity value you can't break it. The image you can break into the pixels like a small boxes. Even the video you can break into the pictures, then later pixels. But these small each box you can't divide into much more parts. If you are dividing like that, there is a damage of the picture. So that purpose, here you have to learn how the image processing is going on exactly. So that is nothing but pixel image. So now I can, and you can understand easily. So because of this, all each and every pixel box is combining, then you are getting the image like this. That is only the definition of the image. But every image you are having the basic size, right? Without knowing the basic size, we can't understand what we are saying exactly. So that purpose I am showing you the basic size is 256 by 256. This is the basic size. 256 rows, 256 columns of your particular picture with a combination of horizontal and vertical lines. So that is only you can say it as image. Now you can see that particular image with the pixel values. But here you can see, if you're selecting any type of picture, definitely it's having some particular extensions. You can see if any person is sharing the picture to you or along with you in your mobile, you're having the pictures. Definitely you can understand each and every picture, how the extension will be there. Why we are having these many extensions in the picture means the quality of the picture will increase or decrease based on these particular extensions. You're taking first one as a file format as giant photographic group is nothing but JPG. You can see if you want to share the picture, sometimes the picture may be 140 KB, the picture may be 100 KB, but that picture may be 1 MB. So what is the difference between 140 KB 100 MB means the quality of the picture based on the different type of formats. So here you can see JPG is nothing but joint photographic group. So here it can give little bit less quality of the picture. But coming to the next one as JPEG. JPEG is the joint photographic expert group. Compare with the JPG. JPEG is the best one because the quality will be expert. Coming to the next one as bitmap image file is nothing but it's like JPG format only, little bit changes will be there. So PNG is more clear format compared with the normal ones. What are you seeing like JPG and PNG? So compare with those. What are you seeing the PNG that is little bit better one. Like the quality of the picture is better. Like that you are having the TIFF and GIF also. You can understand all those extensions. See these pictures, you can understand what are the types of pictures we are having exactly. So color picture, gray picture and binary picture. Let us start with the images types with a basic one. The first one will be colored image. Colored image is nothing but in daily routines where you are seeing the pictures. In daily routines where you are seeing the picture with the extensions and with the different type of the colors, that you can say it as colored picture. So it's having the three type of the colors. What are the colors? RGB, red, green, blue. So how you can see means actually in a Python you can't see that pixel values exactly. I will show you in a MATLAB. Um, but you can understand how it's going on exactly in a OpenCV with a Python also. You can easily understand that particular option. So let us start with the first one. So I'm saying RGB type of image. What are you seeing the colored image? That I can say it as RGB image. Is nothing but red, green, blue combination of the image. I'm saying it's having the three planes. Why it's having the three planes? Because red, green, blue. Three type of colors we are having. For example, in this particular picture, you can see the different type of colors: yellow color, red color, orange color, green color, white color, something, right? So if you want to get all those colors with the different type of the shades, so the RGB value range you have to change. What is the range of the RGB means? Red will be 0 to 255 range, and green will be 0 to 255 range, and blue will be 0 to 255 range. Okay, so that are the options when you are going through with this. So how it will work, I will show you here. For example purpose. So here I am taking INP1 is equal to IM read of one particular image. Okay, so I don't have the particular image means I can download the picture, I can go through it. I'll check the pictures. Okay, for example, I'm having this picture. So just copy the path. So I'm just showing the pixels, how the pixels are there exactly. I have to show, that's why. Now I'm giving IM tool of INP1. So this is only for showing the picture, how the pixels are going on exactly for colored image, for gray image and all. You can see downside you're getting some particular values, right? So that is only meaning of that each and every pixel values are going through with it. You can see this picture. If I'm showing this picture, you can see, so downside you can see pixel info option will be there, right? So here you are having the option XY RGB. So if I'm expanding the picture, you can see downside. Just observe, when I'm scrolling the picture here, the values are changing. X and Y is nothing but rows and columns. Rows and columns will start here 0 comma 0 to, you can see the 0 comma 0 exactly it will start actually. And up to this picture, what is the size of exactly that particular picture, it will display 707 comma 326. I said only 256 by 256, that is basic size of the picture. You can see if I'm scrolling there, then the RGB value colors, I mean values are changing based on the different type of colors. The RGB values are changing. So that's why you're saying it as it's a combination of three planes RGB of colored image. This is colored image only, no? You can see the picture values with the RGB how it's looking like exactly. RGB, red, green, blue. So you can see actually the original picture by giving the lessing the, I mean by decreasing the size of the picture. This is the picture. If I'm increasing the picture, I can see the all boxes with the RGB values. So how the RGB value is changing, you can see. In these color only, you are having different type of shade also, the value is changing. 241, 238, 234. Here you can see 242, 243, 244, 243 is nothing but this one and this one will be related. So what is the meaning of this particular pixel values means? So if you want to get any type of colors in your real-time applications, simple thing you have to change only RGB value range. That's it. The 0 to 255 range will be there for each and every color that you have to change. And it's having 3 bits, 3 bytes is nothing but 24 bits size, basic size. Coming to the next one as grayscale picture. Here in this grayscale picture, you can see it having only the single plane of the intensity. It doesn't have any colors. You can see here you're having the different colors you can observe, but here you don't have any type of colors. Simply you're having the basic color is either white or black with the intensity. So what is the meaning of intensity here? The simple thing. So in our old movies, you can see they'll use flashlights to see the picture properly. If they're not using the flashing lights, then they can't see the picture properly. What is the meaning of that simple thing? So without having any colors, we have to show the picture in a proper way. That purpose, we should have only grayscale content. Is nothing but intensity range. So that I can say it as range with 0 to 255. So that is the option. Um, for grayscale image, you can see the grayscale image, but how many values are there in grayscale image? I said for each and every color, here you're having the range of RGB. Because of the changing of RGB only, you're getting many colors. And also this RGB image, you can call it as primary colors. Because primary, why I'm saying, because of that RGB only, you're changing all colors, you're getting all colors, that purpose. So coming to the next one as grayscale image. So you are just going through the grayscale image, and you can see here how the picture is looking like. So now I will show you the MATLAB process about it. So don't get worried, we'll go through the OpenCV only, but we can't see this particular pixel values in OpenCV, that's why. So here we are having that option. So I am taking here GRP1 is equal to RGB2 gray of my input picture of INP1. INP1. So I'm giving here IM tool of GRP1. Okay, now you can see the pixel values with the single values. Oh, sorry. You can see the second picture. The original picture is converted into the gray picture. So that is only you can call it as image conversion. In second picture you can see you're having only x and y along with the intensity. If I'm moving the cursor, you can see only the values. Where are you having the white color, you can see the max value. Where are you having the black color, you can see the less value. You can see here I am getting 255 max range. This is pure white color. So now I am clicking on the pixel values. You can see the pixel values, how the pixel values are there. Previously, each and every box you're having the three values, but now you're having only a single value. Okay, you can understand this one, how the image processing is converting colored image to the gray, and how many channels are there. So I can see for the grayscale image, I'm having only single channel. Coming to the black and white, so you can observe this particular black and white picture, it's having only either black or white, it doesn't have any colors. So simple thing, you can call it as binary level image or bi-level threshold image, or bi-level image also. It's having the it doesn't have any type of options, it having only either black or white. It doesn't have any particular intensity. This intensity range 0 1 is nothing but that is about black and white range. So that is only we are seeing. So it's having only single bit. So grayscale having 8 bits because single channel will be there. RGB you're having the 3 channels RGB. That purpose 3 into 8, 24 bits. So these are the meanings of each and every types. But why we have to learn this type of images types? Apart from that, we are having so many of conversions. HSV will be there, CMY will be there, many type of image conversions will be there. But why we are using exactly this particular ones means these are the main particular size of the pictures. You can understand that particular picture size, each and everything. So now I will show you the part of this last picture, black and white picture. Now you can see the black and white picture also. It's having only either 0 or 1, not like a range, particular range. So you can see either 0 or 1. You can see here BW will be there, X and Y. If I'm moving the cursor, white means it's showing one color, 1, and black is nothing but 0. You can see the pixel values here itself. If you want to understand, you can see like this. You can move the picture like this. So hope you understand these particular images types. So now let us continue with the next content. So this will be the picture RGB you're taking, red, green, blue. It will work like this. So this is about color to gray, how you are converting exactly. But how you are converting color to gray also, we are having some particular calculations. And color to black and white or gray to black and white also, we are having the calculation just to see how the picture is converting color to gray. If you are converting, the picture should be like this. So I said the right already about the image. That is only grayscale image having already colored image we have discussed. This is the colored image. It's having three type of colors RGB. Because of that you are having the different type of colors. Range will be 24 bits and all. Then you can see here grayscale image. Coming to the binary image, it's looking like this. Next you can see after black and white. So we already discussed about the black and white. Later you can see RGB and CMYK. Actually how the colors are creating means this is only. This is the main thing. So here you can see RGB are the primary colors I said. And what are the secondary colors means CMY. You can see by combining of red and blue you are getting magenta color. Is nothing but pink shade type. By combining of green and blue you are getting cyan color. By combining of red and green you are getting the yellow color. So by combining of all these colors, three colors RGB, you are getting white color. So what is the meaning of that means max range of red, green, blue. Because of the max range of RGB you are getting primary colors. Actually these are sorry. So these are the RGB are the primary colors. Because of the primary colors you are getting the secondary colors here. Yellow, magenta and cyan. So this is about the combination of three colors of the RGB you're getting, white color. So coming to the CMY, you can see here CMY by combining of yellow color and magenta color, you're getting red color. Is it clear? Because you can see here by combining of how you are getting red color here. I mean how you are getting red color here. You can see. So how you are getting red color means you can see here yellow color and magenta color. Because of this combination only this red color is possible. That is only you are seeing in secondary colors. So yellow color and magenta color you are getting red color. Coming to the next one is here if you want to get the blue color magenta and cyan we should get. So here I am having the magenta and I am having here cyan color, then you are getting the blue color. Then later for green color, what you need? Yellow color and cyan color. Here you can see yellow color and cyan color. You're getting the green color. So these are the RGB primary colors and CMY is the secondary colors. What's the meaning of the K is nothing here. So that is about black. So maximum range of RGB you will get a white color. Minimum range of RGB you will get black color. Fully of opposite of CMYK. So maximum range of CMY you will get black color. Minimum range of CMY you will get white color. So that are the primary colors and secondary colors in percentage. Because of these two only you are getting so many type of colors in percentage. That's why you can see in pink you are having so many shades. In black you are having so many shades. In white you are having so many shades. How the shades are possible means because of this particular one. Next one, image processing we are discussing. Okay, so now I'm discussing about the introduction of the image processing. So image processing is nothing but it can do the performing of operations with the images or videos to get the better enhanced output with the useful solutions. That you can say it as image processing. So in this image processing you're having some particular purpose things you can see here. So what is the use of this particular image processing? Till now we have discussed only what are the images, that's it. We haven't seen the definition of the image processing. Now you can see how the image processing is working. So in our words, the regular words I will say, image processing is nothing but, you're seeing the definition, right? So now I'm saying in our regular words, image processing. So where are you having the images? For that you have to do some performing of operations on that particular image. That because of processing of different type of techniques in image processing, that you can say it as image processing. Here you can see five groups they have divided with the image processing. The first one will be visualization, the second one will be sharpening, and third one will be retrieval, and next one will be measurement of patterns, and last one will be image recognition. So these are not only the things, these are main things, that's it. So these are the main steps of the image processing. But in image processing, you are having two type of image processings. The first one will be analog image processing and second one will be digital image processing. So analog image processing is nothing but where are you having the input without making changes you are getting the output means that is about analog image processing. Simple thing. I'm giving to you and you're satisfying with that particular picture, then you're getting the output. That is only analog image processing. Coming to the digital image processing. So digital image processing is nothing but So when are you giving the input image, you're not satisfying with that input image. You have to do some modifications on it by using of the particular solutions. Finally, you'll get the solution output to you. That is only digital image processing. So that purpose, I just want to use the digital image processing here. So I'm taking here digital image processing. So these are the actually the main digital image processing technique will be in a different way. So I will show you that particular part to you. Image processing architecture as per the textbooks, that will be different. That will be we have reconstructed with the small thing. So I will show you the main image processing technique picture. So I will show you the real block diagram. That is only the architecture also. Actually, this is only, but the original picture will be different. So yeah, this one. You can see this one. So actually, this is the original picture of our image processing technique. So this is the original picture. What are you having the image processing? So first we have to take the problem domain. You have to go through the image acquisition, the later enhancement, restoration, color image processing, wavelet multi-thresholding process, then compression, morphological operation, segmentation, representation, and object recognition. Is nothing but the first one to last one you have to go. So these are the steps. What are you having exactly with the particular image processing step? That will be we just convert it into single simple process of image processing. Exactly how the simple process of image processing is going on, you can observe here in a presentation. So this is the simple image processing thing. So you can observe this one, input, pre-processing, techniques and output. Simply we have modified with the understanding type of block diagram. So that is only first you have to take the input that maybe you can get from the any type of devices like cameras, digital cameras, laptops, mobiles or anywhere. So you can get the input, that input you should give to the pre-processing technique. So what is the meaning of the pre-processing means? When are you giving your input image, you have to do better enhancement. Then only you can give to the techniques. Then it will work for it. So that purpose you are saying it as pre-processing. So in these pre-processing, you're having the option, you have to do some enhancement process to the input picture. That only you can say it as pre-process. So what you can do in a pre-process technique means, what you're getting the input picture, you have to adjust the size of the picture, you have to adjust the you have to do any type of conversions you can do, like some modifications you can do for enhancement purpose. Then later you can apply to the image processing techniques. Finally you will get the output. But sometimes if you need image classification with some particular algorithm models, then you can use machine learning or deep learning models after technique of your image processing. Now you can see how the image processing is going on exactly. So in this image processing, we are having some particular type of techniques here. So I will show you the particular techniques with you. Apart from that, we are having many, but I will show you some particular techniques here. The first one will be morphological, second one will be Gaussian, a Fourier transformation, wavelet, and image processing of neural network. So now you can see the first one is morphological operation. So wherever you're seeing the morphological operation, you have to do the dilation and duration. So what is the meaning of this transformation of the dilation and duration means? So you're having the original picture. That original picture, you should get the size of edges with the increasing of that particular edges with the less size or big size. So that purpose you have to use the morphological operation. You can understand easily here. You can see the original image. Dilation is nothing but it's getting expanding of your original input edges to the big size. But you can see the erosion. It's just getting the decreasing the size of the edges. Like that you can take. That is about morphological operation with dilation and duration. The next one will be Gaussian image processing. So what is the meaning of the Gaussian means? So in image processing with the OpenCV, we are having so many type of filtering techniques. That may be smoothing and what is it, enhancement and some blurring, removingness, something like that. You're having noise removingness, like that. You're having so many of options. In that particular area, this Gaussian image processing will work for, so to convert original image into a blur type of image, or sometimes you can convert the blurred image into the original type of image. So coming to next one is Fourier transformation. This is about the Fourier transformation will work for wherever you're having the image processing exactly. So with some particular frequency domain changes you have to do. That purpose you have to work with this Fourier transformation. Actually, this Fourier transformation and Gaussian, these are enhancement techniques, because in enhancement you're having two type of technique, spatial domain and uh, Fourier transformation based. Okay, so in a spatial domain you're having like enhancement and increasing decreasing of the brightness, contrast, and some filtering techniques and all. But coming to the Fourier transformation, so it's like you have to take the transformation with the some particular type of sine and cosine waves. So based on that, you have to make some changes on this particular image. You can see this one. So coming to the next one is wavelet image processing. So wavelet image processing is nothing but it's one type of segmentation technique. Wherever you're having the original picture, in this original picture, it can convert into the wavelet packages. Then it can easily identify the small edges also. You can understand this picture. You can see because of changing of the wavelet packages along with the filtering techniques. So you can see this is one type of segmentation. This is one type of segmentation with the wavelets is nothing but the simple main thing. You have to identify the edges by using of the transformation technique, that you can call it as wavelet based. In that wavelet based you are having so many FFT, DCT, DWT, DTCWT, many techniques will be there based on the increasing of the filtering techniques in that particular wavelets with the transformation based. So coming to the next one is, if you are using this image processing with the neural networks, you want to use this image processing with the neural networks, means I said already, for the classification purpose, something else you have to use for the training purpose. Definitely this image processing we have to work for the neural networks. What it can do means, you can observe this particular picture, so you have to give your database to the neural network construction. It can train your database and you can say that this is cat or this is non-cat something based on your database. So it can identify the features exactly by doing of the classification of the images using image processing along with the neural network techniques, means the deep learning. Then you can work for it. So exactly the main fundamental steps what we are using. I said like mains. Actually, these are the main steps. Whatever I said, wavelets, process, morphological, and all. But everything will be with proper techniques one by one. It's like a planning process. First we have to take the rice, then later we have to go for the pouring of the water, then you have to boil the rice with along with the water. It's nothing but some procedure to prepare the cooking of rice, right? Like that, you can see the main steps what we are having exactly in this image process. So these are the main steps. Previously, what are you seeing? That are one type of things in these particular image processing techniques. The first one will be image acquisition. What is the meaning of the image acquisition? Means you have to acquire the input image from the set of inputs. Example purpose. So you are taking like what is it 100 images you are having, but you can't share that particular 100 images to the people. Whatever you want to share to the receiver person from your sender, you can share. If you want to do any modifications, you can do. So the selecting of the input, what are you doing, the selecting of the input, that you can call it as acquisition process. And coming to the next one as enhancement. Enhancement is nothing but you have to enhance the picture, I said already. So Gaussian is one of the technique in this particular enhancement process. So with the spatial and filtering, I mean, what is it? With the spatial process and as well as like another techniques, then you have to take that particular techniques in that. Filtering is nothing but you have to do the filtering process, color image processing, and compression. We know very well. You have to reduce the size of the content to save the spaces you can use. Segmentation means for the edges, like wavelet, how we used one of the technique in a segmentation. Recognition means feature extraction purpose. So these are the requirements when you are taking exactly. So now you can see till now we have seen the techniques and all, but we didn't see the remaining requirements. The first, so these are the techniques, and we will see what is it. Particular block diagram of the image processing. This is the block diagram of the image processing, right? These steps we can see very individually. Till now, individually, just we have understand what is what. That's it. But step by step, we can see how these techniques are using. So here I am taking the first one will be input, right? The input only you can call it as image acquisition. So you can get any type of input image from your original data, single image or video. That you can call it as image acquisition. That is only in our block diagram you are having the first step on that one. And coming to the second step in that particular block diagram, pre-process. What you can do in that particular pre-process, you can do the reduce the complexity of your input image by doing the resize. So what is the meaning of the resize in this particular pre-process means you can increase or decrease the size of the picture based on your requirements. That you can say it as resize. Coming to the next one is conversions. If you want to do image conversions, color to gray, gray to black and white, then you have to use for it. Last one will be the filtering technique. Having any noise disturbances, you can remove it off. So this is about the pre-processing. Image acquisition is nothing but the first step. You are taking the input image, that is only input, the first step in our block diagram. Second step will be pre-processing. Individually you can see this is the colored image. If you want to do the resize like this, you have to do. Next, RGB gray conversion, how it's converting, you can see. In colored image, each and every pixel you are having the three values, right? We know very well about it. But in gray you are having single values. How it's converting means simple thing. It's taking the average value of each and every pixel is nothing but r plus g plus b by 3. 200 plus 200 plus 200 by 3. Then you are getting 200. 156 plus 143 plus 123 by 3. Then you are getting 143. So average calculations of the picture value, pixel value, then three values are converting into the single values. That is only RGB to gray conversion, how the calculations are going on. Black and white means you can take some threshold value in this particular area, then you can convert into either 0 or 1. Now you can see the how the filtering technique is working. Simple thing, for original image, you have to take the original image into 3 by 3 matrix, then you have to add some particular requirements on it. Coming to the next one as image enhancement. Image enhancement is nothing but you can see the original picture. It's not clear. If you want to enhance the particular picture with the brightness and contrast, you can increase. You can see this second picture. It get enhanced of your original input image. Like that, you can do many type of enhancement techniques. Next one, segmentation. So in segmentation, many techniques will be there. You can see one type of segmentation technique that may be colored segmentation or normal segmentation. Based on the features, you have to segregate. All humans are converted into one color. Road will be one color. The vehicles will be one color. It's nothing but based on the features, you can identify the edges. Based on the edges, you have to identify the features. That edges you are recognizing based on the different sizes. That you can say it as segmentation technique. Next one, in segmentation only, you are having another technique is about the edge detection. Here, edges you have to identify. You can see this is gray picture. For the gray picture, we have applied some region based edge detection. It can identify the edges very smoothly, not like wavelet segmentation. Actually, wavelet segmentation and these region based edge detection all are related to the segmentation only. So simply we have to learn all those things. That's why we're discussing and all. So now coming to the next one is image compression. Image compression, you're having two type of techniques. We already know the definition. You can increase or decrease. You can compress the picture into uh, less size to save the space, right? So in this particular time, you're having two type of techniques: lossy and lossless compression. So one is permanent, one is temporary technique of compression. Recognition having so many, but from that you're having these main requirements: local binary pattern, GLCM, Gabor filter, principal component analysis. These are the techniques again in this particular sub techniques in recognition. So that is the techniques. So it's simply we have discussed all those techniques in a what is it in a within a less time. Apart from that, we are having so many techniques in image processing. And here you can see image processing applications where we are using face recognition purpose in your mobiles. If you want to identify the faces by taking the camera to open your mobiles or to take the pictures in your mobile, that is face recognition. And forensic purpose, you can take the databases, you can identify based on the forensic applications. Next, number plate detection. So in number plate detection, you can see if you want to identify the number plates, the picture you can convert into the some segmentation techniques, then later optical character recognition, then it will work. Next, documents retrieval means you are having so many type of documents. From that single document you have to retrieve means that purpose you can how to use image processing retrieval technique. Next, lane departure warning is nothing but you can see the lanes, right? In a vehicles you can see if you are crossing the lane, then it will give red alert in some particular vehicles. That lane tracking and all is used. It's you are getting because of the image processing with the AI technique along with the deep learning. And like traffic signs, so driver monitoring in a film industries, so security based at anywhere in satellite based, everywhere we are using. Apart from that, you are having some security techniques in this image processing. That is only steganography, cryptography, and watermarking. So let us discuss about the steganography, cryptography, and watermarking of the image processing techniques. Because in real-time application, along with these normal techniques, the security is also very important. The first one will be cryptography technique. So in image processing, the cryptography technique it can work for the visual cryptography process or normal cryptography process by different type of operations. Uh, because of this cryptography, you will give some particular keys to your original input. You want to transfer one particular data from source to the destination. But if any person can hack in between because of your particular addresses and all, right? So you don't want to get like that problems. Then what you can do, you can take the original data, you can encrypt it by using of some particular password keywords. Then in receiver side who are having the person, they should receive that particular option by the decryption process. So like that, if you want to go any full security option, then you have to use. In movies you can see if the main person like one particular political person or a very important person in particular state or particular country, they have to go from one location to another location, definitely that route will be very hiding process, right? Why? Maybe some people will attack that particular important person. That purpose they won't realize, I mean, reveal that matter into the outside. Then what they will do means they have to do this process only. The because of the cryptography, the route map they will provide with the cryptography technique. Coming to the next one is steganography. So steganography is nothing but here you are hiding the passcode technique. Okay, in steganography you are hiding some particular text in your original input data. That you can say it as a steganography. For example, you are having the picture. In that particular picture, for the encryption purpose, you are giving some particular text or some particular code, and for the decryption purpose you are just removing that particular, you are extracting that particular passcode from text message from your particular input image. That you can say it as decoding part. So what is the meaning of this technography? Means simple thing, you're hiding the text in your particular input to get the security. And coming to the next one is watermarking. In these watermarking, you can see most of the things in these particular watermarking. You can hide any type of image type in your backgrounds of your original data. In regular things, you can see this hiding technique of watermarking. For example, from your Pearl University, in a background, if they are giving any content about you, about your college and about your books and about some textbooks or some other, okay, in that particular thing, sometimes you can see they will hide in a background with a watermark. What is the meaning of that? That is indicating this content is done by your college, your university. So that you can set as watermarking process. So these three techniques are for the security based. Apart from that, we are having image processing techniques, that is about image fusion. So what is the meaning of the image fusion? Is nothing but, you know very well, fusion is nothing but combining, right? So here in this image processing technique, the fusion technique will be work for two or more images or two or more videos you can convert into the single output. That you can say it as image fusion technique. In that you are having so many of options. Apart from that, you are having so many type of applications, biometric applications, medical applications, noising removing, and enhancement techniques, image restoration. You can see you are having the old picture means you can convert into the new picture by using of the old picture by making the changes on it. Like that you can do many type of options. Okay, so these are the things. This is about the OpenCV and I mean image processing and all. So simple thing, the OpenCV is nothing but we are using some particular library for it. That's it. So I will show you that also. Just the basic discussion we will do. So how the construction is going on exactly with the image processing, I will show you. Okay. So now you can see, till now we have discussed about the image processing. But how the image processing is working with the OpenCV means, OpenCV is nothing but open source computer vision. That is only you can call it as computer vision library. It's a big technology to work for the image processing technology in a Python language. Not only in a Python language, it's a multi-platform. You can use in C language, you can use in another type of the languages also. Even it's coming in a MATLAB process also. So like that, the computer vision is also the technology to work for the image processing technology. Okay, so it's not only worthable for this particular Python language. You can use in a C language, you can use in a Java language. That is we have to check whether it is available or not. So but we can use in a multiple platforms. How the construction of the library is going on and what is the use of this particular computer vision library means, it will work for image processing to work with the images and videos. That purpose you can understand this particular picture. So you are having the data will be images or with the videos. that you are giving as input, then you have to do the analysis and reprocessing. Then you can apply the neural networks. That is all you can say it as computer vision. So what are you seeing the image processing along with this particular library? For the coding part, you have to use in these particular steps. Now we can see the coding part for this. So for this purpose, I will go through in some particular option here. I will show you an application for this. You can understand easily how it's working, how the image processing is working. So I will show you two outputs actually. That is about how it's working for images and as well as videos. Both I will show you. Then you can understand how the application is going on. So I will show you that particular application by showing of the output. So now I am showing the first application will be uh, deforestation of image deforestation classification. So this purpose, I'm just taking this code, simple thing. This coding of the content is related to the, you have to use the images data set. You have to do the image data set with the classification by using of the deep learning model with the libraries of computer vision and TensorFlow and as well as Keras. So what is the meaning of the computer vision means OpenCV package you have to use for the images purpose to load, to pre-process and to work with the deep learning models, and to construct the deep learning models you have to use the TensorFlow. For that particular requirement, here we are having some particular files. So this is about static for front end part setup purpose, and second will be templates. So if you want to show the output with the template, for the front end part we can use that. And next one data set, and these are the pre-trained model files. This is the training of the data set code. This is for checking code. Okay, so now I'm just copying this particular part. I'm going to particular software. So I'm showing the application with image processing with the OpenCV along with the deep learning model. So this is about deforestation classification we have to do. Means whether it is normal or any deforestation done or not. What is the meaning of the deforestation process means? You're having two type of the labels of images dataset. One will be the normal one, and second one will be the deforestation means any making changes will be there in the forest areas, like they're cutting the trees and they're building the constructions. That will happen means that you can say it as deforestation. So now I will show you that particular option. Okay. Now you can see I'm going through with the detection. So here you can see I'm choosing the file. So from this particular data I have to choose the file. So after choosing the picture I have to detect. It's showing the prediction output will be normal because it doesn't have any deforestation problems. So whatever we are seeing before 5 years, in the same manner we are having. Now again I'm browsing the picture, and now I'm taking another picture. Then it will show deforestation will be happen. But how much happened deforestation means it's showing 37.25 percentage. So in this particular image, previously compared with the last year, you're having the 37.25 percentage of these particular things. So this is about deforestation using image processing with the OpenCV library, OpenCV technology, computer vision technology along with the deep learning process. This is one type of application, how it's working exactly. So apart from that, I'll show you the another application for you. How it can convert images to text. You can understand, you are having the images to images, right? That images, how you can convert into the text, you can see here the output process. So this concept is about image to text to speech. For example, I will take one picture. I'm saving this picture. So this is about image to text to speech. We will try it. So I given my input image name as inp3.jpg. So now I'm running the program. It can do image to text to speech. So for that purpose, you have to use GTTS, PyTestRact, OpenCV, and Pillow package.
And in depth of glance.
You can see what text is displaying exactly. This is the original input image. That image purpose, what you are having exactly, so it's showing it as. So here for that purpose, you have to load the OpenCV library, definitely. Because where you're having the images and the videos applications, definitely you have to use. And Pillow package, PyTestRact, these are for conversion purpose. So you're loading the all libraries, then you're reading your input image and you're displaying. Then image to text purpose, you're using PyTestRact library, then you're converting image to text. Then later what you're doing, the text into speech you have to convert means you to have to convert text to speech because of GTTS or PyTTS. So like that we can try any of other picture also. But text should be little bit clear. So we'll try with the different pictures whether it will work or not.
College decos.
So we'll try with the different type of pictures. But the text should be clear. Then only it can understand very clear. So we'll try with any of other pictures. So like that you can convert into any type of images into a text to speech. So again I'm giving another picture.
This text clips the background image. This text clips the background image.
So like that you can do any type of conversions. So these are possibilities with this requirement. So this is about all how the image processing is working in real-time applications with us in everywhere for our applications. So that will be the requirement for it. So once again, thanks to the Pearl University. Thank you. Thanks to all people who are joined here. Once again, thanks from the college. Thanks for giving this opportunity. Thank you so much. Thanks for giving this opportunity from the College of Pearl University. Thank you very much.